Conditional probability example. So in this video, I'm going to go over a problem that involves the conditional probability as well as Bayes' theorem that is based on conditional probability concepts. So again, first thing I like to do with these, I always just read through them, see what they're asking for, and then I'll go back through and start gathering some information. So we have the germination rate for pumpkin seeds directly related to the prevailing weather conditions. So if the weather is dry, the probability that the seed will germinate is 0.75. Otherwise, the probability is 0.85. And then recent weather history suggests that there's a 40% chance of a dry start to the growing season. And a pumpkin seed is going to be selected at random. So we're just selecting one seed at random. The questions we want to answer: what is the probability that the growing season will be dry and the season will germinate, or the seed will germinate? So that right there, dry and the seed will germinate, that's going to be something like this that we're looking for. So the probability of, I'm going to use D for dry, G for germinate. Hopefully that is okay. But we're looking for that on the first one. What's the probability that the seed will germinate? So we just want the probability of G. And then suppose the seed did not germinate. What is the probability that the growing season had a dry start? So what we're looking for here, they say suppose the seed did not germinate. So that's the condition that's being given to us. And we're really looking for then the probability that it was a dry start given that the seed did not germinate. So those are all the things we're going to be looking for. And let's go ahead and go back through the original problem and start putting together information that we can use to help answer those three questions. So they say weather is dry, probability seed will germinate is 0.75. So if the weather is dry, that's a condition. So what we really have here, we have some given things. And we have the probability that it germinated, given that it was dry, is 0.75. So this was given to us in that second sentence there. Otherwise, this probability is 0.85. So what I'm taking away from that is that, if it's dry, you get 0.75. And if it's not dry, you get this 0.85. So probability germinates given that it's not dry. And I'm using these bars. Some people use a superscript C for the complement scenario, but I just use the bars to indicate that it's not that particular thing. In this case, not dry, or with the bar over the G, not germinating. But at any rate, the probability it germinates when it's not dry is 0.85. And then the recent weather history, 40% chance of a dry season. So we're going to say the probability is dry is 0.40. And that's pretty much all they've given us. We can get other things from this information, but let's go ahead and start in part one here and see what we get. So part one, we want to find this probability of D and G. So dry and it germinates. And usually with the and scenario, you're going to multiply the two probabilities together. The probability of dry times the probability of germinate. However, in this case, because the two events are not independent, the germination is actually dependent upon the weather conditions, we have to use a conditional probability in this multiplication. So the first thing we need to do is multiply this, or I should say put that probability of D down in there, probability of being dry, and then we're going to multiply by the probability that this thing germinates given that it's dry, since the germination does depend on the weather. So the probability is dry and it germinates will be the probability of dry times the probability of G given D. And this is what happens whenever you have those conditional scenarios, or more importantly, the dependent scenario, where one of the things, in this case germination, is depending on something else happening. And in this case, that something else is the weather condition. So looking up above, I have all the information I need. I got the probability of dry is 0.40. I got the probability of germinating given that it's dry is 0.75. And you can just multiply these two together and get 0.3. So your one little individual seed only has a 30% chance of germinating in dry weather. And I should say, more importantly, the probability of it being dry and germinating is going to be 0.3. Make sure I say that correctly, because the probability of germinating in dry weather is 0.75. So sorry about that. But, little bit of specifics on the words there. So dry and will actually germinate. 30% chance that you're going to see these events happening. Okay, now part 2, probability that it's going to germinate. All right, let's take a look at this. So they've only given us, a certain amount of information here. In some ways, black and white, dry, not dry, germinate, not germinate. So I'm going to, again, kind of look at a little tree diagram here. And the germination does depend on whether it's dry or not dry. And if it's dry, you've got either going to germinate or it's not going to germinate. And if it's not dry, it's either going to germinate or it's not going to germinate. Let me see if I can write a G this morning. There we go. So what I'm looking for then for the germination is actually these two branches. And it's either going to happen when it's dry or it's going to happen when it's not dry. Keyword there is or. So I'm going to add together some probabilities in order to get this germination. And what I'm going to actually have then for the probability of germinating is going to be the probability that it's dry times the probability that it germinates when it's not dry. So that essentially takes us down this branch right here on the left. And then I'm going to add that to the probability that it's not dry times the probability that this thing germinates when it's not dry. So looking up above at the purple stuff here that I've got, looks like we have all the information except for one piece. I've got the germinates when it's dry, germinates when it's not dry. I've got the probability it's dry. I need the probability that it's not dry. And again, if we're assuming that this is, a true kind of black or white situation where it's either dry or not dry, then I can use 1 minus the probability of dry to get the probability of not dry. So those two go together to form the whole total of 1. So that means not dry is 0.6. So coming down here then, back to what we got, I can start plugging these in, and we'll get the dry is 0.40 times probability of germinating when it's dry, and that's going to be times 0.75. Go ahead and do it this way. And then plus not dry is 0.6 times probability of germinating when it's not dry. We'll do 0.85. And then you just need to work that out. And we know the first part from part I, and that's going to be the 0.30. And 0.60 times 0.85 ends up being 0.51. And adding those together, you get 0.81. So there's an overall 81% chance that these seeds will germinate, no matter what the, if you're just putting it all together in just a general sense, you got an 81% chance that these things are going to germinate. Not too bad. Okay, so then the last one, we're supposing the seed did not germinate, so that was our given condition, and then we want to find the probability that the growing season had a dry start based on this information. And this one here, this uses the, and make sure I get that written down the way I had it up there. So this is going to actually use Bayes' formula. And, if we look up here at, even part I, we have the probability D and G equals probability D times the probability of G given D. So just looking at this little formula here, notice that if I solve for the probability of G given D, I would have the and divided by a probability. And Bayes' formula, builds on this idea. And really what Bayes' formula says with this particular conditional, which I don't have any information up here about what's going on with the condition being not germinating. I've just got a bunch of stuff when it's dry. So Bayes' formula is beautiful in that it allows you to use more of the information that you have to get some information you don't. And with this scenario, using Bayes' formula, we would have actually this being equal to the probability of not germinating given that it was dry times the probability of being dry all over the probability of being a not germinating seed. So this is really a crucial formula to understand and be good with. So you may want to look at Bayes' formula a little more in order to understand how the math behind this goes, or at least the rearranging. But up top, what we really have here is when you have this not germinating given D times probability of D, that's really this probability of not germinating and D. And again, that kind of flows from this original and scenario with dependent events, where Bayes just rearranged some things a little bit in order to allow for this structure that I can actually use some of the information I have. So let's go ahead and get these different pieces in play so that I can complete this. So the probability of not germinating given that it's dry. Well, going up here to what was given, we had the probability of germinating when it was dry was 0.75. So probability of not germinating when it was dry would just be 0.25. Again, assuming that there's only two possibilities, germinate, not germinate. All right, the probability of dry, well, we already had that. That was 0.4. So we got that piece of information. Just getting this collected again. And then the probability that it doesn't germinate, well, that's where part 2 can come in. We got the probability of germinating was 0.81, so not germinating should be essentially the complement to that, which will just be 0.19. So now I got all of the information I need in order to figure out this probability that it was dry, given that the seeds didn't germinate. And just plugging those pieces of information into that little formula I established, we will be able to get to a final answer. And when you work that out, you get 0.52. I'm going to go out 4 decimal places here, 63, and rounding would leave that as a 3 there. So we have this a little bit better than half a chance that it would be dry if the seeds didn't germinate. Okay, I hope that helps give you a sense of these different ways of using conditional probability. All 3 of these parts use the conditional probability in a slightly different way, which is actually a really neat problem. And again, thank you for watching.